And yeah, he will talk to us about Demokratis, which is a platform for, and it's a non-profit to improve the process for Swiss citizens, as me, to provide feedback for proposed laws. So if you ever looked at the law, you may, I mean, just the published laws are already difficult to read, and the laws in progress are more difficult to read because there are several versions and diffs, and basically you need to find out what changed between the old law and the new law yourself, and yeah, this platform should hopefully improve it. So if you ever struggled with like PDFs containing random data and you need to get something out of it, this talk will probably be for you. So yeah, please welcome Vita.
Thank you. It seems I need to wait for another minute. Oh, here we go. Hi, everyone. It's good to be back. As you may have heard, my name is Vita, and I usually work as a freelancer, and I'm focused on Python performance and distributed systems. But today I'm here because I also do some machine learning and, well, actually mostly data engineering at Demokratis, which is a Swiss nonprofit. And what we're trying to do is to digitize the Swiss Vernehmlassung procedure. Now, I'm curious how many of you know what this thing is. I'm not going to embarrass myself by trying to pronounce it in any of the languages. Almost no one. Interesting. So, the usual way new laws or changes to laws are established is that there is a legislative project. Somebody proposes the text of a new law or an amendment, a change to an existing law, which is then voted on in Parliament, and if it passes, it becomes adopted law. But in Switzerland, there is this interesting intermediate step, not for every single law, but for the bigger ones or more important ones, where the author of the legislative project of the potential law opens it up for public consultation, which means they publish the proposed text, some explanatory reports, letters, slides, tables, and they ask for statements or feedback. And anybody can submit their feedback, although at the moment, in practice, it's usually some focused lobby groups or NGOs that already know about the procedure and they are used to the participation. So this has already been working for decades in Switzerland. What do the consultations look like? In our database, which is probably not 100% complete, but close to it, at this moment, we have over 5,000 consultations. Most of them have already happened, of course. A few of them are ongoing right now. And the consultations consist of a lot of documents. So you have the proposed changes in the law and all the explanations and letters around that. So we have over 51,000 documents, and most of them are PDFs. And together, it's a lot of text. It's 1.8 million pages of PDFs. What's interesting is that these consultations happen on the federal level, but also in each canton. So we have consultations from all the cantons plus the federal government. And of course, multiple languages are being used. We unfortunately do not support Romansh yet. So we only have the 3 major languages. So with all this data that we're collecting, what are we trying to do with it? The first feature of Demokratis is that it is an aggregator of all the consultations in Switzerland in one place where you can search for them, filter, you can subscribe to notifications about new consultations being published. So this is already public. If you go to Demokratis.ch, you can browse consultations. Then the next feature or goal for us is to simplify the participation. What we're trying to do is to make writing statements or feedback similar to the GitHub experience. So you could comment on a particular paragraph in a proposed law, or even suggest a diff how the text could be changed. And this we already also have, but we don't enable it for every single consultation, only after a prior agreement with the author, with the publishing office. And then the third goal is for us to simplify the work for the administration that publishes the consultations, but then they have to collect the feedback and evaluate it. So they actually have to go through all the letters they receive, or the feedbacks, the statements, and often what they do is they copy-paste the arguments and the positions into a huge Excel sheet, which they use as their database, where they try to evaluate what the general feedback is, or the most common points. And this, of course, we want to simplify as well, although this is for us still, this is not built yet, or very, very simple features are built at the moment. And the ultimate goal is to make this old process that's based on documents that at least they are digitized, they're in PDF, but it's still an old world process. So we're trying to make that fully digital and based on machine-readable structured data. So it resembles, for example, collaboration on software. I'm proud to say that we've already started an official pilot project with one canton, Appenzell Innerrhoden. And as of last month, they use our platform as the official place where they published a consultation, and they collect feedback or statements on it already through our platform. So it's a small start for us, but it's a nice validation. So in this problem of turning an old process based on PDFs into the digital age, what kind of problems do we encounter? The first one is quite maybe even funny. When we download those PDFs, we sometimes don't know what they are. By which I mean we don't know if a given PDF is a draft law, or an accompanying letter inviting you to participate, or a report explaining why this law is necessary. This fraction of documents that we don't know what they are is shrinking for us, thanks to the machine learning model that I'm going to talk about, but it's still a significant chunk of the documents. So if you're given a PDF and you're trying to classify it into 9 types of documents, what kind of features could you take from that? Maybe the most obvious one is to take the text of the PDF and embed it. So that's what we do. At the moment, we use OpenAI embedding models, and then we reduce the dimension with PCA of the embedding. So that's the first feature. Then we have some very simple features, like looking for a few keywords that we know are associated with certain document types. So, for example, synoptic tables are very common in consultations. So we have a Boolean feature saying, is the word synops or synops appearing in the document? And then we have a bit more complex regular-based expressions. For example, a formal German letter greeting is strongly associated with either an invitation letter or a statement that's providing feedback on the consultation. And then there are more visual features of the PDF. So, for example, is it portrait or landscape? Or how many of the pages in the PDF contain tables? And those are also interesting features for us. The data set is a bit peculiar because we have a huge corpus of the federal consultations, which is quite homogeneous, but then the fragmented data set of the cantonal ones. And interestingly, for federal consultations, the documents are labeled. And for the The cantons, they're not. So the question we had was, could we train on the labeled federal data set and then use that trained model to classify cantonal documents? And the answer is, it's kind of possible, but it doesn't come for free. We still had to label a lot of cantonal documents to make the data set more representative of what we're trying to do. And since we have this kind of a discrepancy in the data, when selecting the features, it was important for us to compare what's the distribution of the feature in the training set, which is mostly federal, and the testing set, which is all cantonal. So for example, this is a comparison of the synopsis keyword between the mostly federal data set and the cantonal data set. And you can do that for continuous features, of course. So this was an important tool for us to select features that actually make sense across the data sets. Then once we have the features selected, we need a classifier model. So we started with logistic regression back when we had when the labeled data set was quite small and it was an okay baseline. Then it became more exciting as the data set increased and we were able to use a random forest, which was significantly better. But eventually we settled on a support vector machine-based classifier. And we used the hyperopt library for confirming that this was a good choice and the hyperparameters were a good choice. But I have to say that the hyper-optimization didn't really bring any eye-popping gains, maybe 1 or 2 points in the scores. The result of this is that it works. We get decent scores, and we already use the model in production. However, there is always a manual review of the outputs before they are displayed to the public, because we're dealing with legal data, so we don't want to make misrepresentations of what we're republishing on our website. Another problem that's a bit more difficult for us is to recognize what the consultations are about. For example, so you can filter for them or subscribe to consultations about public finance, for example, or healthcare. So these are the topics we have and their frequency. And of course, one consultation can have multiple topics. Now, the model that we currently use is pretty simple. We take the title of the consultation, the name of the organization that published it. We embed each of these. Then we take a few documents relating to the consultation. We need to be careful which ones we select. So typically we select the draft law and the accompanying report and some more. We embed each document and then we average the embeddings. That's a nice feature of embeddings, that they make sense even after averaging. And then we just stack that into a huge vector representing each consultation. And then we scale, reduce dimensions, and classify with a very simple classifier in this case. And why we have this relatively basic model right now is because we still don't have so many good labels for consultations. We're still working on actually manually annotating probably a few hundred more. As I mentioned, it's important to choose the documents that you use for this carefully, but it's nice to see that after solving problem 1, classifying document types, we can use those results here. And we have a vocabulary of topics that we assign, but we've discovered, maybe it's obvious, that some topics are more difficult than others to model because they are very broad and the definition maybe encompasses a lot more consultations. So the model, we do have a model that's also deployed, but we've restricted it to predict only 9 topics that it's good at. And most of the topics we have, it doesn't try to predict because the scores are not good enough, not yet. Now, of course, you might be asking if there's a better way to approach this problem. And of course, we could use large language models because they're magical and they solve all the problems. So we could prompt it, give it a few examples of what our topics are, or maybe definitions of what the topics mean, and then ask it to classify a document. But unfortunately, we haven't had great success with that, at least so far, where the scores were significantly worse than a specialized old school model. But there might be another way, and that is taking a domain-specific language model, a language model that was trained on legal texts, and just fine-tune it, add a classification head to it, fine-tune it so it works as a classifier. And I did some experiments with that a while ago. There actually is a family of models trained at the BFH in Bern on Swiss legal texts. And the result seemed promising back then. But since then, we've significantly changed the topic definitions that we have. And we haven't gone back to this experiment yet. But we really want to do that. Of course, the training then takes orders of magnitude longer than just sklearn classifiers. Another problem that I have alluded to already is getting a machine-readable structure out of the document. This we need, for example, so we can enable that GitHub-like interface where we can comment on very specific parts of the law. So the problem is taking a PDF and turning it into a machine-readable structured format where you see what the paragraphs are, the headings, the sections. So maybe it's JSON-based, XML-based, doesn't really matter. Now, this again sounds like something you could upload into ChatGPT and ask it to give you back JSON. And it's probably the way, because the traditional products that you get for extracting structure from PDFs, which is on AWS, Adobe Cloud, Azure, in my experience, they fall short of really understanding the structure of the legal documents. There is LlamaParse, which is similar to those products, but it has an LLM built in, so you can prompt it and instruct it how to extract the structure, how to represent some features in the PDF. And a volunteer who I met at this very conference last year actually dedicated significant time to help us experiment with LlamaParse. So thanks to this conference, we've had some experiments with LlamaParse, which seem to indicate that this is the way to go. There are at least 2 projects I'm aware of which are open source and could be alternatives to LlamaParse. I'm looking forward to the DocLink talk later today. And the other one is Marker, which also recently added LLM support. And why we are not really progressing very much on this front is that even with the LLM support, the outputs need a lot of manual review and checking, because what routinely happens is that the model leaves out parts of the law text or inserts its own content, which typically is in English in the middle of a German document, saying, here is your markdown formatted document. So I'm looking forward to seeing an actual bill being voted into law that contains LLM output. That would be really funny. But so we're not doing this yet because we would need significant time to manually review everything and compare it to the PDFs. And as I may have mentioned, it's a non-profit project with a fairly limited budget at this moment. Another problem that's currently in the works is a pretty cool one. It's a proof of concept that we're working on together with an AI consultancy called Visium. And we were contracted by the Bundeskanzlei to build a proof of concept application that will help them analyze the statements coming in, the feedback on the laws, and maybe connect parts of the statements to the law being proposed or parts of the law, and evaluate, do some sentiment analysis, clustering of the statements. So this is a proof of concept work that has already started and should be delivered in a few months. So we're really looking forward to seeing what comes out of that. At conferences, I always like to hear practical experience and lessons learned on the battlefield, so to speak. So I always try to include some of that in my talks. So I'd like to say a few words about what we've learned working on these problems. A painful one was garbage in, garbage out. We have data and labels coming from various sources that do not really agree on the definition of what the labels are. And I desperately tried to use as big data sets as I could to train models, even though the labels were not really consistent, and it just didn't work. It's much better to reduce the data set to a core that you know is good. Maybe train just logistic regression, get some okay results, and then get to manually annotating or subcontract manual annotation of more data, so you can grow this good data set. And for prioritizing this work, we found the library called CleanLab a great help. What it does is you run it on the probabilities predicted by your model, and you also show it the data set that was used for the model, and you ask it to find potential issues with your data, and it runs a couple of checks and shows which of your data points, sorted by some sort of a score, are the most suspicious, or the model is having the biggest trouble with those data points. So this may lead you to check that the labels are correct, for example. And we also wrote a tiny function that takes the CleanLab outputs and converts them into an Excel sheet where you can compare the data points with the outputs from CleanLab, and you can include a link to the platform itself, so you can see the consultation that's being problematic. So this was, it's probably 20 lines of code, but it helped very much with the prioritization of the people who do the manual reviews. Another lesson learned, and this is actually another hint I got at this conference last year, was to use DuckDB as the data loading layer. So what I was used to doing until very recently was just reading Parquet files with pandas, filtering, and then joining to get my final table that I work on. But that is pretty slow, and it consumes a lot of memory that is basically wasted. So here is a memory profile of a data pipeline that just loads a few tables there, a couple of gigabytes, and filters them, joins them, and then you get a result that you can work on. And you will see it peaks out at 15 gigabytes of RAM. For no reason, you never actually use so much memory in the script that runs afterwards. So the alternative is to use DuckDB, create an in-memory database that's empty. You create a select statement that selects data from a Parquet file hosted in S3, for example. You define the selection, the filtering criteria, and this is just a declaration. This doesn't do anything yet. Then you can do the same for another table, and then you define a join between the tables, and only when you call to data frame or to arrow or polars, at that moment, DuckDB goes into your S3 storage and starts pulling only the data it actually will need. It's very efficient. And you'll see that the same thing now peaks at 6 gigabytes instead of 15. And the only change there was how the data is loaded. And maybe the final thing is pipeline orchestration. We've been using Prefect, which is pretty pretty cool. It's a system which lets you compose data processing pipelines or inference pipelines, whatever you need. It has caching built in. You can monitor the logs. You can run tasks in parallel. You can have dependencies. This has been working quite well for us, but I will admit I will start looking for a more data-centric solution, because Prefect feels like a general purpose orchestrator for pretty much anything you would want, but you have to kind of invent your own naming schemas and passing data or incrementally updating data sets. There's a lot of engineering work that I had to do that I expect in a platform like Dexter or maybe ZenML would be abstracted away. If you have experience with these things, I want to talk to you at the conference today. This is a link that goes directly to our GitHub page, because everything I've been talking about is open source on GitHub. So you can check out the research notebooks where the models are trained, and the inference pipelines or the pre-processing. And on GitHub, you will find also a link to our Hacking Face repository, because also the data we work with, we automatically publish. It's another Prefect pipeline that crunches the data and publishes it weekly. It's pretty hands-off. And there's also a link to our public Slack in case you want to tinker with the data and want to ask questions, then we're there. Here's the link again, and I'm happy to take questions now.
All right. We have time for questions. Are there questions in the audience? There's one there. The mic is on its way. Please keep your hand raised.
Hi, thank you. I have a question regarding the feature extraction. Have you tried using term frequency versus document frequency? And regarding the models, you showed that random forest was one of the best. No, you used random forest. I'm asking if you also tried like some boosting method.
Yes, so the first question was TF-IDF. We did try that, and it wasn't terrible, but it always underperformed embeddings. So at some point, we just stopped trying. But yeah, we did try it for several of the problems. And the second question, gradient boosting. I'm not very familiar with this family of models, so I did try a little bit, but not too deeply. I did specify some search space in HyperOpt, so it would explore this a little bit, but I don't really have the deep knowledge of the model to be able to say if I was using it incorrectly or it just underperforms. Maybe I should have explicitly mentioned that not only the work is open source, we do welcome contributions or even just ideas. So if you have good ideas how to make this work better, please do get in touch.
Another question over there.
Oh, hello, great. I have two parts, the database and image captioning. Once you have your data extracted, what database do you use? And is it easily supportable with vector search? And the second question is image captioning. Are images important in your data sets? Do you need to turn them into text for you to then have it be searched and processed and understood? If so, how?
To the first question, I have an extra slide, which is we try to do things very simple. So there is no vector database. I really wanted to try a vector database. I evaluated a few, but I always came back to storing Parquet files in object storage because at the moment the project is still quite simple, and everything we do can run in batch jobs. So it's not strictly necessary for us to use a database. So we just have Parquet files. It's not very sexy, but it actually works. And the second question was about images. As far as I know, they are not crucial for us because they appear mostly in the explanatory reports for the consultations, where, for example, there would be a map of some part of Switzerland with things highlighted, or some charts of CO2 emissions, for example. And we do not need to process this data, not yet. It may happen in the future, but for now we're focused on the text. And in the legal drafts, the only images are logos of the Swiss Confederation, for example, or the cantons, the flags, and sometimes scanned signatures of important people.
There's a question over there.
Thank you for a great and interesting talk. I wanted to ask, how good does the model have to be for it to be sufficient, right? If you have to pick one thing to work on this project, there are several things you could choose. You mentioned, for example, this GitHub-like way of viewing documents. And already a precision and recall of 90% is quite good, right? So like this might even beat the processes we have today. And so how much effort do you want to put into making the models perfect, kind of?
Yeah, this is a difficult question because it's not just about statistics or the technology, it's also about the human element, because we do want to have that human review or human check of the outputs. Maybe not for everything all the time. For example, document types, at some point we will be comfortable to just not reviewing and only displaying a disclaimer on the website saying that the document type was generated by a machine learning model. But for the, so I guess what I'm trying to say is the model can be as terrible as we want, but then we need to allocate a lot of human time to reviewing and correcting the outputs. So it's a balancing act because there's just a few of us on the team. So yeah, I don't have a set number. It would be a discussion between the reviewers and the people who build the models.
Right. Last question over there.
You mentioned this nice CleanLab tool that you use to identify suspicious predictions that humans have to look at. Is there a way in this tool to actually then to check what did it rely on to make the final judgment, which label is suspicious and which not?
I'm not sure if I understand the question.
Well, it relies on, so it has a list, you show the list of different checks that were done. Most likely it's not all of them that contributed equally to the final decision that prediction number 5 is the most suspicious. So most likely there is one of them, I do not know, the number of nulls or the actual score value or whatever, or range of score values in the cross-validation, whatever, that one is the most kind of driving force for the identification of suspicious predictions.
I see.
Is there some way to kind of using this tool to find out what did it rely on, what was the driving force?
I think it's quite transparent because it runs a few checks like a potential label issue, non-IID distribution, potential duplicate labels. And these checks are independent of each other. So we actually look at them separately. And in our experience, the label issues were absolutely dominating the results, and the others were just a handful of problems that we quickly fixed. But then the label issues pointed to either weird labels or inconsistent labels, or they just said that this is apparently a difficult data point because the model mispredicted it terribly.
So thank you, Vita.
Thank you.